You know that picture of the solar system you have in your head? The one from school with all the planets on a neat, flat track? Yeah, well, that's a lie. A flat lie. Today, we're going to tear up that 2D drawing and show you the wild, three-dimensional truth about where we live.
So check this out. On the left, you've got that tidy picture we all learned. Sun in the middle, planets orbiting like cars on a racetrack. But the reality? Well, that's over on the right. It's a glorious mess. It's more like a swarm of bees, with orbits tilted and crisscrossing all over the place, a real 3D dance.
All right, let's start smashing that flat image to pieces. Because, spoiler alert, the planets do not play by those neat, flat rules. And their orbits? Far from perfect.
And look, the numbers don't lie. We use Earth's orbit as our sort of baseline, right? But even our next-door neighbor, Mars, is tilted off that plane by 2 degrees. Mercury's is off by 7. And then you get to Pluto, which is just doing its own thing, tilted at a crazy 17 degrees. Already, that neat little picture is getting pretty wobbly.
But if you think that's a lot, get a load of this. Halley's Comet has an orbital tilt of more than 162 degrees. That means it's basically flying backwards compared to all the planets. So this isn't some tidy record spinning in one direction. It really is a chaotic swarm with things buzzing every which way.
So this raises a pretty obvious question, doesn't it? If everything is tilted and moving all over, how in the world do we even define up and down in space? We need some kind of cosmic compass, a way to get our bearings.
So how do we make sense of it all? We start with something called the ecliptic plane. It's actually pretty simple. You just take the path Earth follows around the sun and imagine stretching that path out into a giant infinite flat sheet. That becomes our cosmic sea level. From there, we can measure if something is above or below.
And you know what? The same idea works on a much, much bigger scale. If we zoom all the way out, our entire galaxy has one too. It's called the Galactic plane. It's that dense central disk where most of the stars in the Milky Way hang out. Think of it as the ecliptic plane for the whole galaxy.
Okay, now that we've got our compass, we can finally start our journey. We're going to head out from the sun, and as we go, you're going to see that our solar system isn't a disk at all. It's actually a series of massive, layered structures that form a giant sphere.
The first layer we hit is actually pretty subtle. It's this huge cloud of really fine dust, basically the ground-up leftovers from billions of years of asteroid collisions and comets falling apart. But here's the key. This dust isn't just flat. It forms a thick lens that sits above and below the inner planets. It's our first real clue that there's a third dimension here.
Once we get past Neptune, we hit the Kuiper Belt, and this is where the flat model just gets completely shattered. It's a totally chaotic region, filled with icy bodies and dwarf planets like Pluto, Haumea, and Makemake. And they're all on these wildly tilted orbits that soar high above and dive way below the main plane where the other planets are.
And if you keep going, you reach the scattered disk. Now this is where you find the real oddballs. These are icy bodies that got a huge gravitational kick from Neptune a long, long time ago. Their orbits aren't just tilted, they're super stretched out and unstable, which sends them flying deep into the outer solar system.
Just look at that number, 45 degrees. Some of the objects out here have orbits tilted more than 45 degrees. That means they're traveling almost perpendicular to the rest of the solar system. This is the real frontier, and it's proof of just how chaotic our system's past really was.
So all of this chaos, the tilted orbits in the Kuiper Belt, the flung-out bodies of the scattered disk, it all leads to this, the Oort Cloud. This isn't a belt or a disk, it is a colossal spherical shell made of trillions of comets that completely surrounds our entire solar system. This is the ultimate proof. Our solar system isn't flat, it's a sphere.
But there's another kind of boundary out there. This one isn't made of rock and ice. It's made of energy. It's the sun's own personal force field, the true edge of its influence.
It's called the heliosphere. The best way to think about it is this. The sun is constantly blowing out a stream of charged particles, what we call the solar wind. This wind rushes out in all directions, and it inflates a huge magnetic bubble around all the planets. This bubble is what really separates us from the rest of the galaxy.
And the power behind this bubble is just staggering. The solar wind is moving at somewhere between 400 and 800 kilometers per second. That constant, incredible pressure is what keeps the heliosphere's boundary billions and billions of kilometers away from the sun.
And we know for a fact this bubble is real because we've actually touched it. Back in 2012, Voyager 1 finally crossed the boundary, way up above the ecliptic plane. Then, 6 years later, its twin, Voyager 2, crossed that same boundary way below it. That's the definitive proof we needed. The heliosphere is, without a doubt, a sphere.
Okay, for this last part, we're zooming all the way out, because our entire solar system, this huge sphere we've just been exploring, is itself just a tiny little boat sailing through even bigger, almost ghostly structures within the Milky Way.
So right now, as we speak, we are sailing through something called the local bubble. It's a huge 1,000 light-year wide cavity in space that was hollowed out millions of years ago by a bunch of massive stars exploding. Basically, we're in a bit of a cosmic void where things are about 10 times less dense than the galactic average.
But the bubble we're in is nothing compared to what's out there. Astronomers have found that our entire galaxy is sandwiched between something way more mysterious: two absolutely colossal, invisible bubbles of energy.
These are the Fermi Bubbles. Each one stretches 25,000 light-years out from the galaxy. They aren't made of normal stuff. They're giant structures of high-energy gamma rays, probably blasted out by the supermassive black hole at the center of the Milky Way. If our eyes could see them, they'd be one of the biggest things in the sky.
But underlying everything, the bubbles, the stars, our solar system, is the ultimate mystery: dark matter. It's this invisible substance that we can't see or touch. It's believed to be the cosmic scaffolding, the invisible skeleton that's holding our entire galaxy and all galaxies together.
And this really puts things into perspective. Everything we can see, all the stars, planets, and galaxies we've ever observed, that only makes up about 15% of the matter in the universe. The other 85% is this mysterious dark matter. It's a cosmic ocean that surrounds everything, above us, below us, and all around us.
So you see the pattern, right? We used to think the world was flat, until we found out it's a sphere. We thought the solar system was flat, and now we know it's a sphere. It just makes you wonder, what huge, fundamental thing about our universe do we believe is true right now? Is just the next cosmic lie waiting to be uncovered?